So, why might you want to study differential equations? Well, the primary reason is that differential equations are useful for building models of systems that are changing over time. So, if you look carefully at the title for this course, the course is titled Differential Equations and Dynamical Systems. And all that means is systems that are dynamic, or in other words, that change over time. Now, if we want to describe those systems, we'll often have a variable. In this case, we'll use y to represent the state of the system. So as an example, here we've got some sort of tank. It has a fluid in it, and y represents the amount of fluid in the tank. And if we want to know the value of y at each point in time, we'd like to have some function that tells us how to compute that. The problem is, it's not always obvious what that function should behave like. However, differential equations allow us to talk not just about the values of y, but also about the derivatives or the rate of change of y. And it turns out that there are many contexts in which finding a representation for the rate of change is much easier than finding the representation of the function itself. So let's write down an equation for not y, but the derivative of y with respect to t. So we want to know how fast y is changing. And in this case, there are two things that would cause y to change. We have some input, some fluid is being added to the tank. So if you can make sense of my drawing, we've got a little faucet here. So it's adding fluid to the tank. And so that's going to cause y to increase. And so whatever that is, I'll just use words, right? Input rate, and its units would be in liters per minute, perhaps. And if I subtract off the output rate, which output comes from, it looks like we have a faucet letting some fluid out of the tank as well. We now have a complete description of dy dt. If I know the input rate and I know the output rate, then the rate of change must just be the difference between those two. Now, in this course, what we're going to learn is how do we take an equation like this one, which describes the rate of change, and go back and use that to compute the original function. How do we find an expression for y of t from dy dt? So that's one part, solving the differential equation. And the other part is actually coming up with the model in the first place. So we'll get some practice over the course of the next few weeks constructing an equation that describes the rate of change itself.